At present, the electrodes of high-temperature fuel cells are mainly made of catalyst materials, such as electrostabilized zirconia of solid oxide fuel cell and nickel oxide electrode of molten carbonate fuel cell, where low-temperature fuel cells are mainly composed of a thin layer of catalyst material supported by a gas diffusion layer. For example, platinum electrodes of the phosphoric acid fuel cell and proton exchange membrane fuel cell. The main function of the electrolyte diaphragm is to separate oxidant and reducing agents and conductants. Therefore, the thinner the electrolyte diaphragm is, the better. But the strength also needs to be considered. For the current technology, its general thickness is about tens to hundreds of millimeters. As for materials, there are two main development directions at present. One is to make porous diaphragm with insulating materials such as asbestos film, silicon carbide thick film, and lithium aluminate film. Then immerse them in molten lithium potassium carbonate, potassium hydroxide, and phosphoric acid to make them adhere to the diaphragm hull. The other is to use perfluorinated sulfonic acid resin, such as proton exchange membrane fuel cell and electrostabilized zirconia. The collector, also known as a bipolar plate, has the functions of collecting current, separating oxidant and reductant, dredging reaction gas, etc. The performance of the collector mainly depends on its material characteristics, flow field design, and processing technology.